This is the FSA Need to Know packet, pages 6 and 7. We are going to do standards EE1 and EE2, which talks about exponents. And again, make sure you're listening to this video if you're watching it. We're on page 6, no calculators. We want to simplify. All right. So we have exponents. We have the same base. Our base here is 2. Okay, and when we multiply with exponents, our powers are being multiplied, we're going to add our exponents together. So we're going to keep that base, the base of 2, and we're going to add 3 plus a negative 2. All right, so let's do this here. This is going to be 2 to the, well, 3 plus a negative 2 is 1. And 2 to the first power is just 2. All right, the second one here, again, we have the same base. The base is 4. And since we're multiplying, we're going to add those exponents. Negative 3 plus 2. Okay, and negative 3 plus 2 is now a negative 1. So it's 4 to the negative first power. And when you have a negative exponent, remember we have to flip it to the other half of the fraction. Well, it's not a fraction yet, but I can make this into a fraction. Let's put it over a 1. Okay? We want to flip this down to here and make it positive. So this is the same as 1 over 4 to the positive 1 power now, which is just 1 over 4. Okay, so when you have a negative exponent, you flip it downstairs to the other side. If it's already in the denominator, you flip it up to the numerator and make it positive. Let's do number 2. This time we are using division. Okay, we have division of 3 to the third divided by 3 to the fourth. We're going to still keep that base. The base is the same, the base is 3. And now we're going to subtract our exponents. 3 minus 4. Always the top minus the bottom. Okay? And 3 minus 4 is a negative 1. So this looks like the one we just did. Okay, let's make this into a fraction. I haven't changed anything yet. Okay, since it's a negative first power, I want to move it to the other part of the fraction. Okay, so then it's going to be 1 over 3 to the positive 1 power. When you move it, you take away the negative sign, which is just 1/3. All right, let's do the next one. We have the same base of 2. When we subtract our exponents, it's negative 3 minus, well, what exponent is in the denominator here? 2 to the positive first power. So when I subtract, it's negative 3 minus 1. So this is going to be 2 to the negative fourth power. Okay, same idea. Make it into a fraction. Okay, you're going to move this down here because it's a negative exponent. It needs to go in the other half of the fraction. So it's going to be 1 over 2. Instead of having a negative fourth power, it's now going to be a positive fourth power. But what is 2 to the fourth power? That's just like this. I'm going to do it over here. 2 times 2 times 2 times 2. Okay, we're going to multiply these together. I get 4 times, I multiply these together is 4, and 4 times 4 is 16. So that's what goes in the denominator here. So it's 1 over 2 to the fourth, which is 16. Okay. Number 3, simplify. All right, some silly rules here. 5 to the 0 power, anything to the 0 power equals 1. That's it. Anything to the 0 power is 1. All right, and anything to a negative power, just make it a fraction. Okay, and then just like we did before, we want to move that 9 down here because it's a negative, so this will be 1 over 9 to the positive first power, which is just 1 over 9. I'll circle this one too. That one was easy. All right, number 4, simplifying. All right, now we have a power raised to a power. You see that with the parentheses? The power of 3 is being raised to another power of 2. When we raise a power to a power, now we're going to multiply those exponents. So keep our base of 10, and now we're going to multiply 3 times 2. Well, that's 10 to the 6th power, and if we do that out, it didn't tell us if they wanted it in exponent form or not, so that's really just 10, a 1 with 6 zeros. 1, 2, 3, 4, 5, 6. Okay? If it were me, I would have probably left it as the 10 to the 6th power, but it says simplify, so I'm thinking they want us to write it all the way out with no exponents. All right, this next one. We've got a lot going on here. All right, we have some multiplication up here. Then we have a power raised to a power, and then some multiplication. So we've got a lot of stuff going on. So let's start with simplifying the top. A different color so it's easier for you to see. So keep that base in the top, and since we're multiplying, we're going to add those exponents. 2 plus 2. Okay, that's our numerator. Our denominator, let's do the power to a power first, this thing. So we're going to keep our base of 4 and multiply 3 times 2 in our exponent, and then we still have this guy, we still have a times 4, and that's just to the first power. All right, simplify some more. 4 to the 2 plus 2 would be 4 to the 4th power, divided by, let's see, 4 to the 3 times 2, that's 4 to the 6th power, and we're going to multiply it times 4 to the 1st power. I'm going to move sideways here. I'm going to keep the numerator for a second, and let's combine our denominators here. 4 to the 6th times 4 to the 1st, since the operation here is multiplication, we're going to add those exponents. So 4 to the 6th plus 1 is 4 to the 7th power. All right, and then, hopefully you still have room, we're going to do this. All right, now we're going to do our division. So keep your base, subtract your exponents. Okay, and that leaves us with 4 to the negative 3rd power, which now we're going to change into a positive exponent. All right, we're going to move the 4 down to the denominator. It's going to be 1 over 4 to the 3rd power. Almost done. That's just 1 over 4 times 4 times 4, which is, let's see, 4 times 4 is 16, times another 4 gives me 64. Woo. That one was long. Okay, that one's tricky, but we know all the steps. You know everything. You know how to do things. Turn it to the next page, page 7. It says it on the bottom, page 7. We are on standard EE2. We're solving for x when we have exponents, okay? We did this recently here. When you have x squared equals something and you want just plain old x, how do we get rid of this squared sign? Well, we do the opposite, which is a square root. So the square root of x squared will get rid of the squared and leave me with x. Well, if I do the square root to one side, I have to do it to the other side. Okay, square root of x squared is just x. So now I have x by itself, and I know the square root of 81 is 9. But since this isn't a problem with length, I could also multiply another number times itself to get 81. Let's write this over here. 9 times 9 equals 81. Think about your negatives. If I have negative 9 times negative 9, doesn't that still equal positive 81? Well, in that case, x can also equal negative 9. Okay? It doesn't really work when you have a power of 3, like in the second problem here. Okay, to undo this power of 3, I'm going to need to take the cube root of x to the third power. So whatever I do to one side, I do it to the other side, taking the cube root of 125. Okay, see, so getting this cube root here and this 3, they cancel each other out. So all that's left here now is an x. All right, and the cube root of 125 means what number times itself 3 times gives me 125? Well, let's see. I know the answer is 5 because 5 times 5 times 5 equals 125. So the answer is 5. And it doesn't work when I do negative 5s. Negative 5, it always has to be the same number times itself. This will become a negative 125. So that doesn't work. So that's not an answer. It's just plain old 5 to get me to 125. All right, number 3, again, solving for x. We have the square root. So in this case, we have really the square root of 25 over the square root of 100. That's what that means. You can break that up. That's a property. Okay, so you know the square root of 25. That's just 5. And the square root of 100 is 10, right? Because 5 times 5 is 25. 10 times 10 is 100. That's how I get those numbers. And let's reduce this. What can I divide by? I can divide by 5 to reduce. 5 divided by 5 is 1. 10 divided by 5 is 2. That is my most simplified answer for x. Okay, we can do the same thing with cube roots. We already have x by itself. We just need to simplify the right side. Just like we did before, we can break it apart. So if the square root, excuse me, the cube root sign goes over the whole thing, then we could also do the cube root of the numerator over the cube root of the denominator. Well, the cube root of 1, what number times itself 3 times gives me 1? Well, 1 times 1 times 1 is still 1. So this is just 1. And what number times itself 3 times gives me 27? I'll do it over here. 3 times 3 times 3 gives me 9 times another 3, which is 27. So the cube root of 27 is 3. And that's simplified. Okay, I believe that's it for that lesson. Let me check here. Yep, so now you're going to look for assignments in Google Classroom.